Have you ever wondered what your operating system's up to? What's it doing right now? This video's playing, but what's it doing? Well, welcome to another episode of 5-Minute Computer Science. My name is Mr. K, and today we're going to be looking at the operations going on in the background. So, you're going to be learning about scheduling, interrupt handling, peripheral management, all the kind of things that make your PC do what it's supposed to do and you don't even know about it. So, let's put 5 minutes on the clock and let's learn operating systems.
Okay, so let's have a look at round robin and the method used by the operating system to handle multiple processes. So the method that you're looking at here is very straightforward. The idea behind it is that a round robin CPU scheduling algorithm is used to assign a fixed time, and that's the bit you need to bear in mind. It's a fixed time. So 3 different processes, each requiring a certain amount of cycles of the CPU. So process 1 requires 3 cycles, process 2 4 cycles, and process 3 3 cycles. The order they arrived, and then we can work out the order in which the cycle is going to be used. So in the very first cycle of the CPU, process 1 is executed, then process 2, then process 3. And then we go back and carry on whatever needs to be done in process 1, then process 2 and process 3. And then on the third cycle, you'll notice because only 3 cycles are used for process 1, that's now finished. It then moves to process 2, that requires 4. And then it moves to process 3, and process 3 is now finished because they've been executed 3 times. And therefore, process 2 now is executed straight away. There's no need for process 1 because process 1 is already finished after 3 cycles. Another method used is called first come first serve, a bit like a normal queue at a supermarket. The idea behind this is that the CPU looks at what time did they arrive and then processes those requests according to time. So process 0, arrival time 0, and therefore it's going to be served straight away. So this is the delay in service. So this will take 5 cycles in order for it to be completed. The next process arrived, it required 3, and its service time is 5 because of course you need to wait for the first process to finish. So the first process finished, then it's this one here. When that's finished, the next one arrived, arrival time is 2, and it requires 8 execution cycles. So the service time is essentially the first 2 execute times added up together, which gives you the service time, and so on. So 16 is made up of 5, 3, and 8. Another method used is called shortest job first. Now shortest job first is quite a nice little method of making sure that the job with the least amount of time required to finish is executed first. So in this instance, if you notice, all the same processes from the graphic before. However, because the execute time for process 1 is the smallest, this is executed first. Once this is completed, the next shortest job is process 0 because its execute time is 5, so that's then completed. The next one is this one here, and so then that is completed. And the service time is how long you need to wait. Well, that process doesn't have to wait because it's executed straight away. This process has to wait 3 cycles in order for it to be completed. This one has to wait 8 because of these 2, and then this one has to wait 16 because of the others added up together. One of the jobs of the operating system is to manage the backing store, so it needs to swap data in and out of the main memory, RAM, and it might be doing virtual memory, it might be doing cache memory, but its job is to manage backing store, so pull in operands, pull in opcodes, whatever it means. You might want to pause and have a read through that. It also is responsible for peripheral management, so your mice, your keyboards, your monitors. It's responsible for printing, so any data that needs printing or any word that needs printing is sent to the printer via the operating system. And lastly, I want to talk to you quickly about this, which is the interrupt handling. Now, we all know what interrupts are, but typically an interrupt would be a Control-Alt-Delete interrupt that we as the user generate, but a interrupt can be for many different reasons, and you can see here the priority levels of the interrupts. So if you reset the PC, that's the lowest value here and therefore the highest priority.